sparks never seem to fail, helping scientists from the start. Every 5 steps up 100 times, decrease in brightness, so the stars get dimmer. You see, the closer the star is, the brighter it gets. The farther it goes, it becomes less delicious. Apparent versus absolute magnitude, both assisting in how the stars get viewed. Apparent is how bright the star appears, and absolute measures them in light years. Similar to apparent, but measured at a distance from Earth in 10 parsecs to see their existence. Laws can be used in any place, but today we're taking it to space. We're measuring the brightness of the stars, these shining lights beaming from afar. Just one equation to solve it all, a few simple steps in this protocol. We're measuring the brightness of the stars, there ain't nothing clearer than the way they shine. These sparks are so beautiful and divine, the way they light up the sky.
Astronomers studying space-time, planets and moons, observing all the galaxies, not that y'all looking for typhoons. A scale of magnitude corresponds to a change of around 2.5 brightness in a way. The lower the number, the brighter the star. The higher the number, the star is dimmer. Scientists analyze the brightness of the stars using logarithms to calculate the stars past Mars. Stellar magnitude is for this occupation, relying on their calculations to gather this information. Logs can be used in any place, but today we're taking it to space. We're measuring the brightness of the stars, the shining lights beaming from afar. Just one equation to solve it all, a few simple steps in this protocol. We're measuring the brightness of the stars, there ain't nothing clearer than the way they shine. Sparks are so beautiful and divine, the way they light up the sky. Dating back to 129 BC, was a Greek astronomer Hipparchus, a smart man indeed. He invented a scale in which to measure stars' brightness, listing stars in 1st to 6th magnitudes based on their lightness. In the 1st magnitude were the brightest of the group, while the 6th magnitude were the dimmest. Oh shoot, almost forgetting about Mr. Claudius Ptolemy, a Greek Roman astronomer, adding to his discovery in 140 AD, creating the system of astronomical magnitude scales, adding words greater or smaller to distinguish stars and tails. Scales are soon later defined to be logarithmic. In 1856 by Norman Pogson, in a quick sense, the human eyes respond logarithmically to the intensity of light, and that is how the magnitude scale came to measure stars so bright.
The magnitude equation, a simple calculation, finding the differences of brightness to give education to astronomers who need a bit more explanation. Imps of 1 and imps of 2 are 2 stars' magnitudes. Now that we have the magnitudes, we can solve for the ratio of their brightness. B's of 2 over B's of 1 is what we use. Subtract the first magnitude from the second, and set it equal to this logarithm. 2.5 log times B's of 2 over B's of 1. Now just plug in your number, solve, and then you're done. An astronomer discovers something special about a dim star that has a magnitude of 8.5. She wants to tell her students how much dimmer the star is in Sirius that has a magnitude of negative 1.5. We plug in these two magnitudes, imps of 1 minus imps of 2. Turn the log into exponential. Inverse operations are influential. 2.5 to the power of 10, and should get an answer of 10,000. Now we know how to calculate the ratio of the star's brightness today. Laws can be used in any place, but today we're taking it to space. We're measuring the brightness of the stars, these shining lights beaming from afar. Just one equation to solve it all, a few simple steps in this protocol. We're measuring the brightness of the stars, there ain't nothing clearer than the way they shine. These sparks are so beautiful and divine, the way they light